All right. The last practice exercise in lesson 5 is going to be to create a parametric sketch. We've done this before. Create and extrude. Done that before. Use fillet. I think we've even done this before. Maybe it was just in sketch mode, but you can also do it after you've extruded. And then we're going to use the shell feature, which is can be really useful in some instances. And so let's get right to it. Let's open the design trigger lock. Got to exit out of this one. Save. Okay. So upload. Trigger lock. Open. Upload. Close. Open. Trigger lock. Great. We've seen this before, I think at the end of lesson 4, and it's just a canvas of the reciprocating saw. I think we want to look at it from the right side, but I'm not positive. Yeah, we do. All right, open the design trigger lock. Okay, create sketch lines to roughly match the trigger lock on the image. All right, so that means we have to create a sketch. Let's create a sketch on the right side here. And we'll come over here to the trigger lock, and we got to create a sketch that roughly looks like the trigger lock here. Make sure to close your sketch out completely. All right. Okay, I'm fairly happy with that. Drag this out just a little bit. Yeah, close enough. Might move this guy. Yeah, that's close enough. Okay. Apply dimensions to approximate the trigger lock shape. Okay. Well, the best way to do that is going to be, let's first get our angles right. Oh my God. Okay. So let's say 60. It's going to be a little bit more than that. 62. We're running parallel there. That's good. Let's say 126 looks pretty darn good too. And wherever we're at here, 106, that's good. Now we can't do this corner. It's going to over define it. See this pop-up error, and that's because we've already defined 3 of the 4 angles. So the 4th angle can be inferred by just taking 360 and subtracting all 3 of these. So we don't have to actually define this angle. The next thing we want to do is define the edge, the lengths. I would say this length looks pretty good, simply because this edge is really close to the trigger, and this edge is, it could be slightly less if we wanted to, say 29, and see what that does. See, that brought it in a little bit closer. And then the height could be a little bit shorter. Let's say 14. Let's go even less. That brought that in, which is good. Brought that out. Okay. Yeah, I like that. I think that looks good. Okay. Apply dimensions from the origin to a single point on the trigger lock to sketch, the trigger lock sketch to fix it in place. So what they're saying here is, we are more or less fully defined. We might have to do one more dimension on the shape itself, but we also have to fix it in space to fully constrain it. So let's do that. Let's do it off of the bottom left corner with respect to the origin. So we'll give it we'll give it height, and we'll give it length. So we've given it coordinates. The other way we could do this, instead of giving it the XY coordinates, is draw a line here and make it a construction line. Okay, and then okay, and then give both a magnitude for this and an angle measurement. Oh, well, we need one more point here. Okay, so 2 construction lines, and then come in and give an angle. So this is radial coordinates here, which would be an angle and a magnitude. And then if you want to do Cartesian coordinates, you can just do X, Y. Sweet. Okay, so we've used polar coordinates, an angle and a magnitude to define its location, and yet it's still blue. So we need to come in here and figure out why that is. One way to do that, as I've shown before, is you can start clicking and dragging. All right, and we notice that this thing is able to rotate, which we don't want. So I'm just gonna click Control Z and get it back in place. So what I might do, if to make it so it can't rotate, is define it, a corner with respect to the another corner that has already been fully defined, and we fully define the bottom left corner. If we define the upper corner with respect to this bottom corner, then it becomes rigid. All right, it's fixed in space. We're happy with that. Finished sketch. Now we're going to extrude the closed profile into 3D to represent the trigger lock. So extrude, and I don't know how far they want us to extrude it. They don't say, so let's just pick a distance. Let's see what 10 millimeters looks like. Yeah, it looks good enough. Okay. And then it's saying to add fillets, add small fillets to the edge of the trigger lock, solid. Okay, so we've got the solid piece here. You can apply fillets in sketch mode in 2 dimensions and then extrude that profile, or you can extrude the profile without the fillet and then add it after the fact. Both are going to yield the same results. So let's go in and let's highlight all of our edges, or I guess these 4 edges to begin with. Actually, I'm going to extrude the back edges as well, and I'll show you why in a second. But not the front. And let's just do like a 1 millimeter radius, maybe a little bit less because it's such a small trigger. All right, or trigger lock. Okay. And then we're going to, at this point, I'm going to turn off the visibility on the canvas so that we're looking just at our trigger lock. All right, note you can add as much detail as you want to the trigger lock body. The small recesses shown in the image should be done before the shell. So what they're saying here is anything that you do to the exterior of this thing before we use the shell command, it should be done before shell. Because after shell, if you go to modify it, it won't update. That doesn't make sense until we use shell. So I'll show you real quick. We're going to click on shell, and we're going to click on the face that we want to be open in this piece. So we want this face to be open, and we want the wall thickness to be, let's say, 0.5. All right. So what did we just do here? We turned this object into, we kind of hollowed it out, if you will, or we created a shell with an even wall thickness of 0.5 millimeters all the way around. So if I were to go in and say measure the wall thickness from that face to that face, it's going to read a distance of 0.5 millimeters. So this wall is 0.5, this one is. And the shell command is a really quick and easy way to create uniform walls in a hollow or somewhat hollow object. Could be a tube, it could be, say, like a vase or a bowl. And in this case, the trigger lock button is hollow inside and with one open face. And the shell command is really quick at doing that. If we come down here and suppress this feature, then we see the difference between fillet and no fillet. You can suppress any number of features. This is new. I'm just throwing it out there. You can suppress any number of features to see what the part will look like without, if they weren't done. So here we have our part before we added fillets, unsuppress, and that's the finished piece. See if they have anything else. Nope. All right, that's that.